Okay, now let's talk about resistors, right? Let's start off with a quick review. Resistors can look like this in a circuit. Let's say that's a 10 ohm resistor. If you put in there, that circuit has a resistance of 10 ohms. If you put two in series, you've got 20 ohms. If you put two in parallel, you use this formula and you get something like 5 ohms, right? Remember, voltage is equal to current times resistance. That's a big equation that comes into play often. But what actually are they? What do they look like? Well, typically, they look something like this. I don't know if you can see it. Yep, there we go. That's a brown stripe, a black stripe, and a gold stripe. That's a resistor. But so is this. Come focus. That's an orange, yellow, and gold. And so is this. That's a brown, green, yellow, and gold. You can have a lot of resistors, right? These are the really common ones. They're ceramic resistors, and they're most typically used. Now, how do you know how much resistance something has, right? How much resistance a part has? Well, you can use an ammeter, but you can also just read the color code off of it. There's a very specific color code where the first two colors, or three sometimes, but it's just usually just two colors correspond to the digits. So let it come to focus again. That's brown and black. Brown is 1, black is 0, so that's 10. Then the third color represents the multiplier. Okay, what does that mean? Well, if you have black, that's a 1 times multiplier. If you have brown, that's a 10 times multiplier. The next color onwards is red, and then you have orange, and it's the rainbow colors. And then the last one you have is gray. So it goes like black, brown, red, orange, yellow, green, blue, purple, and all the way to gray. That's what the color codes of the resistor represent. So if I have this one, let's say, for example, that's brown and black, 1 and 0 times brown. Brown is the second one, right? So that's 10 to the power 1. If it's the first one, then it's 10 to the power 0. Second one is 10 to the power 1. Third one is 10 to the power 2. So on and so forth. You can get a formula for that. That's a 100 ohm resistor. But what's the gold line? The gold line is a tolerance. It represents the range of accepted values. So gold typically means, oh, it has a really good tolerance. It should be pretty accurate to around 100 ohms. Let's take a different one here, right? That's orange. Orange is 3. And yellow is the one right before it, 2. Yeah. Can you come to an idea of what... yellow is the one right after. That's 4. Can you come to an idea of what the resistance for this one is? Let it come to focus. Yep. 3, 2, 1. Okay, that's a 3 times 10 to the 4 minus 1. So 1,000, you get something like 330K of resistance. That's all it is. But you have more than one type of resistor. You have this one. This one over here is a potentiometer. It doesn't look like a typical potentiometer, but you can spin it all the same. It's got 3 poles, right? One of them is connected to the moving one. The other 2 are fixed resistance. So if I pull it across this one, they would just have a constant resistance. If I put the wire across this one and this one, it would have a variable resistance as I turn the top. You can have different kinds of variable resistors. You've also got resistors called LDRs, which are light dependent resistors. As the light goes up, the resistance tends to fall. Yeah. You can have thermistors, which are heat dependent resistors. Now thermistors are really weird, but let's just focus on these resistors. As these resistors get hotter, the ions inside them vibrate more. This leads to a higher resistance because electrons find it even tougher to flow through, thereby decreasing current and hence increasing resistance. So as you use resistors more and more, or as they're in a circuit getting hotter and hotter, their resistance in fact increases. That's been a brief overview on resistors. Let me know if you guys want anything more, and you can contact me via the contact page.